Why do we need to transform colors into other color spaces? This is Vahid from CNL. In CNL, we present some courses, some scientific facts, or some stories. If this video is interesting for you, please like the video, subscribe, and share it with others. So why do we need to transform colors into other color spaces? In previous videos, we talked about how to measure color, and we talked about different color spaces. A basic introduction to color spaces. So the most famous one is RGB. For different reasons, it is possible that we need to transform these RGB values to other color spaces. For example, we said that in other color spaces there are other information that are presented or that can be achieved. For example, you can have information just about saturation or just about color, or right, purity of a color, for example. So this is very important to bring our RGB color, RGB image to another color space and take advantage of the information that we have. This is primarily used in image processing and color image processing, and helps to, for example, detect objects, to extract colors, and to classify, for example, some features, some objects. Other interest or other goal can be to facilitate our calculations, that we bring our image to another color space. Other goals can be, for example, an analysis, or just we can say analyzing lights in our images, so we bring it to another color space. Other needs also are possible, like for example, bringing our image to another color space and use the image in that color space, because it is used maybe for comparison, for reproduction of color. In that case, maybe it is better to work in a standard color space. For example, if you bring your colors into XYZ color space or into LAB color space, they are much better for comparison, for reproduction of colors, and we can say that it is more interesting for professional work on images, professionals in color science. Herein, then, because of these goals, we need to change our RGB values to other color spaces. I would like to start with XYZ color space as most common in maybe scientific world, and after that we can take a look at some other color spaces also that are quite common, that maybe you would like to transform your RGB values to those color spaces. So let's continue on the screen. Alright, so first, for RGB to XYZ, you see that we have some formula. Alright, what is the problem? Actually, we have this XYZ, okay, to be obtained. So we say that we have three values: red, green, blue, RGB values, and we need a transformation matrix that is M. All right, so we want to find this transformation matrix. Okay, this transformation matrix can be found from this formula. Then you fill these values and After that, so just by a multiplication, matrix multiplication, we will have XYZ. All right. But however, this is very, very important, you know, to note that for this transformation, you need the exact information of your light source. You need the power distribution of your light source to have a precise transform, which leads to a precise transformation of your RGB to XYZ. This means what? This means that any image that we have taken by our cell phone, we have taken by our cameras, or we find on the web, actually by this transformation matrix, if you bring them to XYZ, okay, actually this is not a very precise work. This is relative, okay? To do this precisely, you need to have the information of your light source, okay? I insist on this because this is very important. So the question is that actually on different software, for example on Python, in OpenCV, or on MATLAB, there are some functions that just bring your RGB to XYZ. All right, they convert them, and maybe you have this question that you can use them just easily, and they themselves consider all. But I'm telling you, this is a relative work that we do for, and your final values are not very precise because you didn't consider your light source. If you have the light source, and normally the light source that has been used in all those you know, functions in OpenCV, in MATLAB, or elsewhere, normally they are based on the transformation matrices that have been taken based on the 65 light source. Okay, so if you have the 65 light source, yes, now you can take your camera, you can measure the RGBs, you can take images, you can extract your RGB values, and now you can use the transformation matrix that I present you here for obtaining your XYZ. But you may say that, no, we have just RGB images and now we want to have the XYZ or other color spaces. That's the same story, all right? For all of them, if you want to bring it to, for example, LAB, still it is important to have the light source or take images under D65. If not, you know that you are if you are using the functions, for example, on Python or on MATLAB, so still it is okay. Still it is just a relative work that you are doing, but the results are not very precise. And if it is for research, or it is like you want to report the absolute XYZ values or LAB values, no, actually this is not precise. So I have now you see that how we obtain, for example, a transformation matrix, okay, in this case. Okay, so in this formula you need XR, YR small. Okay, these values are primary values, okay, that I have provided here for you. All right, based on NTSC standard. You can use these based on PAL, sorry, standard. You can use these, and ITU, you can use these. Okay, maybe it's better to use just PAL because NTSC is not much used, actually recently, and PAL is a standard that is used in Europe. Also, ITU is a standard that is used. Also, you may use one of these two. However, so we come back to our formula, and now you see that these values, you have them, and we need to find uh, SR, SG, SB to put them here, all right? For finding these, you have this matrix, but you need XW, YW, ZW. What are these? They are XYZ values for your white reference, okay? So by having this, okay, by having the white and taking the XR, YR, and ZR from the formula that I showed you, from the matrices that I showed you, so you find M. The M that now is found based on D65, actually now you have them here and you can use them. All right, it has been done. All right, but if you are taking images under sun, under fluorescent light, just everywhere, you should know that the final XYZ that you are obtaining is not much precise. All right, but still you can do it. But still you can do it for your image processing. But the information was important for me to transfer it to you. Then now that we have M, okay, here, all right, you can take your RGB to XYZ. For XYZ to RGB, just you need to inverse the matrix here that you obtain, all right? However, now this has been calculated actually for different kinds of RGB, all right? And it is on the web, and you can use them. One of these websites that I would like to share with you is this, okay? And I will put the link in the description. So here you have the formula, you have some good information here, and here you find these transformation matrices. We call them general transformation matrices that you can just use them for transforming your RGB to XYZ. Okay. Here you find it for other kinds of RGBs under some special reference white. You see always they are mentioned, okay, to be sure that you use the right reference white and you take the exact values. Okay, so so this transformation is not hard, okay, and it is something easily that we can do it. For example, now we can as an example, okay, we can try it in MATLAB. Okay, so just let's try, okay, one of these techniques. All right, for example, just in MATLAB, so I need to define, for example, my RGB. Okay, just simply I want to write it. I don't write a complete code. So for example, we will say that I have 0, 0, and 0. Okay. One important point that I forgot is that if your RGBs are between 0 and 255, for better result, it's better to normalize them between 0 and 1. Okay, so we define our RGB, and then we said that our transformation matrix, that here you see, you can come and choose it. Okay, for example, you see that which RGB you have, and um, just based on your reference white also you can check and take the transformation matrix that you have for the transformation. Okay, for example, we can say that we have sRGB, standard RGB, under D65. Okay, so and we come and define our matrix. So you see that everything is ready. The values, just you need to copy and paste them here. So I do this also quickly. Okay, so I don't know if I wrote all precisely, but however, you try to be precise, take your matrix, copy it here, and now what we need X by Z. Actually, this I need to transpose it, okay, for the matrix multiplication to be true. After this, what you have just M multiplied by RGB, okay? And just you need to execute, okay, and here you go, you have your XYZ that are 0 0 0. All right, so if we have complete white, okay, it will be 1 1 1 and execute, and here it is, okay. And for bringing your XYZ to the right scale, actually, because this also is normalized, so you need just a multiplication by 100. Here XYZ is not 255, and just you will see that this is the right values for the highest values, okay, for the white, okay, that you have your X is the first one, your Y and your Z. All right, so this just as a practice. All right, however, I would like to this process, okay, can be done easily on the websites. Okay, here I will show you some examples. There are some websites just I searched, and they are not limited to these websites, and you can search and you can find any website that you like, but there are a lot. For example, this website. So you select your RGB, and here so you convert insert color data, so it is inserted, and I need to refresh maybe. Okay, I'm disconnected. So normally it should work now. So you put your values and convert. You see the transformation to other color spaces, including X, Y, Z. All right, so this was for X by Z conversion. Just take a look at the RGB to HSV conversion. Herein I also put the information for RGB to HSV. Actually, you don't need extra information, and HSV is actually a color space based on RGB. So again, you start with just normalization, okay, to 0 and 1, and then a bit of calculation, and then you will have your HSV values. Next one, for RGB to LAB, you have these again formula, but for doing this, actually you need to transform your RGB first to XYZ, and here you see that for doing this, the formula is using a general transformation matrix that just we have the table here, all right, one of these, and then changes the XYZ to LAB. LAB is a very interesting color space that is close to human eye understanding of the world. And the last one, so I have put here the calculation for transforming your RGB to CMYK. All right, so I can show you other websites. For example, here again you can put values for RGB or for RGB, and it shows you a preview of the color. All right, for example, if I make it brighter, all right, and then you will have a lot of information, okay, and HSV, HSL, or this website also. Again, you put your all RGB values and it gives you, for example, CMYK. Here there's another one that again you can choose your input system, the standard RGB. For example, I choose pure green. Okay, it shows you the color, and it gives you LAB, it gives you XYZ, it gives you CMYK. So these are also nice for a bit of practice. So I hope that you liked the video. If it was interesting for you, don't forget to like the video, don't forget to subscribe, and be with us in this journey into the world of colors. See you soon.